In this video, we will learn how to classify alcohol and thiol groups as primary, secondary, or tertiary. This skill is important because later on in future videos, when we learn about different types of reactions that these molecules will undergo, we will find that primary, secondary, and tertiary groups react differently, and hence it's really important and essential, actually, to be able to distinguish between these three types of classifications. Let's go ahead and take a look at that in more detail. Taking a look at how to classify alcohols and thiols as primary, secondary, or tertiary, we're going to look at this topic together for both of these because the system for classifying them as primary, secondary, or tertiary is completely analogous between these two groups. And remember that the OH group oxygen and the sulfur from the SH thiol group are in the same column of the periodic table, so we expect them to behave very similarly in terms of how they form bonds to other atoms, and hence the classification of those using a single system works out really nicely. So in the case of alcohols, we'd have an OH group directly connected to a carbon. In the case of a thiol, we would instead have an SH group directly connected to a carbon. In order for the molecule to be classified as an alcohol or a thiol, that carbon has to be directly connected to R groups that we refer to as either carbons or hydrogens. So we'll define here that R is equal to a carbon or a hydrogen. And in the case of these three R groups here, they don't have to all be identical. They don't have to all be carbons or all be hydrogens. It could be a mix of the two. So I'm going to distinguish between the three R groups by calling them R, R prime, and R double prime, to emphasize that this group does not have to be identical to this one, and that does not have to be identical to that one. The common thread is that each of these has to have a carbon atom here or a hydrogen atom here at all three positions. And the number of carbon atoms that are directly bonded to the carbon in green, that carbon in green that I'm now highlighting, is the carbon that's directly connected to the hydroxy group of the alcohol or the SH group of the thiol. We count how many of those R groups, R prime and R double prime, are carbon atoms that are directly connected. And the definition here of primary versus secondary versus tertiary is primary, which we will abbreviate with a primary symbol, 1 prime there, refers to there being one direct bond from the carbon that is bonded to the OH or the SH to another carbon. Secondary is going to refer to the situation where we have two direct bonds from the carbon that's bonded to the OH group to another carbon, or it could also be the carbon that's bonded to the SH group to another carbon. So you will see a trend developing here, and that trend is that primary means one direct bond, secondary means two direct bonds, and so we can infer here accurately that tertiary, or third degree, will refer to three direct bonds from RCOH or RCSH to another carbon atom. And that's going to be as high as it goes. Anything beyond that would need to violate the octet rule in order to do so, and we never violate the octet rule because the max number of carbons that could be directly bonded to this carbon that's part of the alcohol group is going to be 3 because there's 3 R groups here to fill the complete octet for these. Let's apply this information toward an example problem or two. I'm keeping those definitions up in the left corner so that they're handy for us to refer to as we draw out a structure and we attempt to assign it as primary, secondary, or tertiary. I'm going to go ahead and draw out a line angle formula here for our structure. I'm going to draw a few structures here for us to get comfortable with assigning these as primary, secondary, or tertiary. Drawing line angle formulas out because those require the strongest knowledge of who's actually connected to whom, because there's so much information there that is implied rather than shown out explicitly. But regardless of what type of structural drawing I draw, such as a Lewis structure, a condensed formula, or whatever else, you should still be able to assign primary, secondary, or tertiary to any of the groups here. So let's do one more structure here. And now let's take each of these and assign primary, secondary, or tertiary. After I do one or two of these, I would encourage you to hit the pause button, try the rest on your own, and see how you're doing with it. Let's start in the upper right-hand corner. We have in the upper right corner our carbon right here that I've highlighted. That's the carbon that's part of the alcohol group. Alcohol group is there. Classifying this as primary, secondary, or tertiary. I'm going to put a green highlight dot on each of the carbons that are directly bonded to the carbon of the alcohol group. There's one here and one here. So therefore, based on our description of what defines secondary having two direct bonds from the COH to another carbon, we can define that this has to be a secondary alcohol. So I'm going to second degree alcohol here. Alcohol because there's an OH group present in the molecule. Let's go down to the next one, going straight down the page here. I'm going to again highlight in pink what makes the alcohol group is that carbon that's directly bonded to the hydroxy group, OH. And then we count the number of carbons that this carbon of the alcohol group is directly connected to. We have one here, and then one here. And therefore, we would describe this as a tertiary alcohol. There are 3 direct bonds between the alcohol carbon to other carbon atoms, hence tertiary. What about next? Let's go on down the page here to our first thiol. In the case of a thiol, our carbon right here is directly connected to the SH group, so that's what I'm highlighting as my frame of reference. Then we count the number of carbon atoms that the thiol carbon is directly linked to. I'm going to put those in green like I have the alcohols. So we have a carbon here directly connected to the thiol carbon, a carbon here directly connected to the thiol carbon, and one here directly connected. And therefore, we would describe this structure as a, don't call it a tertiary alcohol because it's got an SH group, call it a tertiary thiol. So plug that in. Last but not least, or maybe least, depending on however you want to look at it, taking a look here, we have our carbon atom of the thiol group. I'll go ahead and highlight our sulfur and hydrogen there as well. Then we count the number of carbons that are directly connected to our thiol carbon. There's one here and one here. Therefore, we would refer to this as a secondary thiol. So second degree thiol because it has that SH group, secondary because the thiol carbon right here is directly connected to 2 other carbons. We don't look at things further away like these carbon atoms right here. Look just at what's directly connected because that's what's ultimately going to determine much of the physical and chemical properties of these molecules, and hence it's important to be able to classify these according to this terminology. Let's do one more example to test our knowledge of both recognizing the alcohol functional group and classifying each alcohol as primary, secondary, or tertiary. We'll take a look through the structure of erythromycin, shown here, a common antibiotic molecule, and using that as an example, we will test our knowledge for describing primary, secondary, and tertiary alcohol groups. Okay, let's start by identifying all of the alcohol groups. For alcohol groups, we're looking for a hydroxy group, that's an OH group, that is not directly connected to a carbonyl, a carbon-oxygen double bond. Taking a glance through the molecule here, I see a OH group right here. On all bonds connected to it, I do not see in any of those cases that any of these connected bonds are carbonyls, so we're good to go there. Coming along here, we have another hydroxy group that also will fit into an alcohol because we have carbon here and carbon here. Neither of those are carbonyls, so we are all good to go there. Hydroxy group here. Neither of these bonds that are connected run to carbonyl groups, so all is well there. Coming through here, this group is carbon-oxygen, carbon bonded to a carbonyl, so that's an ester group. Don't pick that. Coming over to here, this is an ether group because we have a carbon, oxygen, carbon, and neither of those carbons are part of carbonyl groups. Coming through here, we have another ether group here because that's a CH3 group out at the end of the line. So we have a COC bond. Down here, we have an alcohol group that I will go ahead and highlight so that we can identify that as primary, secondary, tertiary. I think that covers everything in this ring. Coming on over to here, we have another ether group, another ether group. This is an amine group out here, recalling the functional group information. And this is our hydroxy group of an alcohol right here. It's an alcohol because looking into the left and the right at any of the carbons that are directly connected here, none of those carbons are carbonyls. So we will indeed call this an alcohol functional group. I believe that takes care of every single OH group within this molecule, all of which are part of different alcohols. Now we go in and do the work of assigning these as primary, secondary, or tertiary alcohol groups based on how many other carbons are directly connected to the alcohol carbon. Taking a glance through this, looking down at the bottom, we'll start. The carbon of the alcohol group is directly connected to other carbons here and here. I will put green highlight dots on those here and here, and that allows us to classify this carbon, or this alcohol group as a whole, as a secondary alcohol. And I'm going to abbreviate secondary ROH, where that is our standard abbreviation for an alcohol. That R group there is defined as a carbon chain or ring of some sort. Coming over to here, we have another alcohol to classify. Relative to the carbon of the alcohol group, which is highlighted in pink, we have a carbon here and a carbon here. That enables us to describe this as a secondary alcohol as well. So I'm going to call it a secondary ROH as my abbreviation for an alcohol, because there's two directly connected carbons to the hydroxy group carbon there. Up here, taking a look at this, don't let this one fool you. Relative to our carbon of the hydroxy group, we have another carbon right here, one right here, and then we have this one at the end of the line, that methyl carbon. So this would become, as a result of having three direct bonds, a tertiary alcohol, a tertiary ROH. Then coming on around the ring here, the big ring that is, following this giant ring structure right here of this antibiotic molecule, we find that we have our alcohol group here. This alcohol carbon is directly connected to here. So it's connected to one carbon atom here, and it's connected to one carbon atom right here. So it's connected to two carbons in total here and here. As a consequence of that, I am going to label this alcohol group right here as a secondary ROH, a secondary alcohol. Then, last but not least, we come to the carbon atom right here that I've drawn my line to. Counting the number of carbons that are directly connected to there, we have, relative to the carbon of the alcohol group, we have a carbon right here, we have a carbon right here, and we have a carbon right there. So that's 3 in total, making that a tertiary alcohol. What we will see for erythromycin and other molecules is that during metabolism, the body metabolizes and recognizes differently primary versus secondary versus tertiary alcohol groups, and the types of reactions these will undergo as they're metabolized and passed out of the body will differ. And so that's one reason why it's important to be able to recognize the differences between these different alcohol groups, is because it will result in implications about how these molecules are processed and metabolized and react within biological systems such as the human body. To conclude, out of this video, you should now feel comfortable and competent with assigning any carbon atom from an alcohol group or a thiol group as primary, secondary, or tertiary.